All right, so probably one of the bigger discoveries to come out of forces is the Lorentz force, which is this force that objects experience, charged objects experience while moving through a magnetic field. What makes it such an interesting force is the idea that the value, the size of the force, is directly proportional to the velocity of the object. But that seems very counterintuitive because, as we learned previously, the velocity is relative. So when we talk about this force, you end up getting an acceleration, which is something that you really can't fake. You feel an acceleration, you feel a push or a pull, but the value, the size, the magnitude of that depends entirely on your velocity, which is something that is relative. So there's a real big problem there when we talk about the Lorentz force. It does get sort of resolved when we start trying to connect electrostatic forces in with this Lorentz force. I won't go into it in major detail, but it's a really interesting thing to note. Okay? All right, so the equation for the Lorentz force is the charge of the object multiplied by its velocity. Now, this is where people tend to get a little screwy. They forget that V stands for velocity in this case and not for voltage, because we just got done talking about potential, but that's charge times velocity crossed with magnetic field. That's not multiplication, it's a cross product. I've got two vectors to deal with, okay? So with these two vectors to deal with that I'm going to multiply together, I have two options. I have a dot product and a cross product. The cross product keeps the integrity of it. It also produces a third vector, which we're looking for, because we're looking for a force. But that force vector turns out to be perpendicular to the other two. Okay, cool? So the charge multiplied by the velocity crossed with the magnetic field gives it the force, the Lorentz force. Okay? So if I had a positively charged particle moving in this direction, okay? And if that positively charged particle experiences a magnetic field. Now the magnetic field in this case has all sorts of dimensions in which it can exist, but I'm going to choose the magnetic field to be coming out of the board. The reason why I'm choosing it to come out of the board is that I want my two vectors, my velocity vector and my magnetic field vector, to be perpendicular to each other, because it makes things a little bit easier. Okay? So the velocity is traveling in this direction, the magnetic field is traveling in this direction. The result of this product, the numerical response to this, is going to be QVV. Okay? That's going to be the numerical response of this situation. Okay? The other way you can look at it is that it's QVV sine theta, where theta is the angle in between those two. Okay? Cool? But more importantly, what you're going to run into in this situation is trying to determine the direction of that force. So I'm going to go over the right-hand rule really, really quick. So QV, positively charged, so it's going to be positive vector. So if it was an electron, my vector would end up being in this way, but because it's a positive charged particle, it's going to be in this direction. So what you do is you take your right hand, and you put it in the direction of that vector. Boom. Okay. Now my magnetic field is coming out of the board. So what I'm going to do is I'm going to curl my fingers into the direction of the magnetic field. I need to flip it and then curl my fingers into the direction of the magnetic field. My fingers are pointing into the direction of the magnetic field. The magnetic field is going that way, so my fingers need to be pointing in that direction. The result, my thumb, is the direction of the force. So an object with a charge moving in a positive charge with a velocity moving in this direction, the magnetic field in this direction is going to give me a force in this direction. Okay? So this charge will experience a force in that direction, which means that it's going to start to accelerate. Cool? That's the basics of the Lorentz equation. There's a lot more we need to talk about, but I just wanted to start with that.